Hey guys, my name's Lindsay, and today I'm going to take a few minutes to look at subtracting fractions with you. And sort of the key to subtracting fractions, I've written up here, it says that the denominators have to be the same. Denominators as in these bottom numbers at the bottom of our fractions. So if I look at this question, 9/15 subtract 1/9, I can't just subtract that because these two bottom numbers, the denominators, aren't the same. So we are going to find, and I've written it over here, we're going to find the lowest common denominator between 15 and 9. So let me show you how we're going to do that. We're going to start by, pick one of the denominators. I'll start with 15. I'm going to count over here on the edge here. I'm going to count by 15s. I'm going to make a list of numbers. And this list could go on forever. I could count by 15s, but I'll make a list counting by 15s, and I'm going to do the same with the 9. So I'm going to count by 9s. And again, this list could go on forever. I could count for 9s all the way to the floor. But what I want to do with these lists is find a lowest common denominator. So I want to find common, meaning looking at the numbers that are here and finding numbers that are the same, and lowest as in the lowest one. If we've got repeat numbers, if there's more than one number on those lists that are the same, I'm going to pick the lowest one. Now if I look at this list counting by 15s and I look at this one counting by 9s, it looks to me like 45 is the lowest common denominator. And on this list, there aren't any other repeats. But if we kept counting, eventually we'd run into other matches. But what we're most concerned about is the one that is the lowest. So now that we've got that figured out, we're going to go back and we're going to make these both into 45s so that the denominators are common and we can add them together. So the way that we're going to do that, for the 15 first, I'm going to go back to my list and I'm going to say, okay, 1, 2, 3. If I multiply 15 by 3, it's going to turn into a 45. But if I do something to the bottom of a fraction, I need to do the same to the top. So I'm going to multiply that 9 by 3 as well. I'm going to go over to this list, count down to the 45. 1, 2, 3, 4. I see 5. So I'm going to multiply 9 by 5 to make it 45. Better do the same to the top. So now I can rewrite this fraction as 9 times 3, which is 27, over 15 times 3, which is 45. That's why we chose 3. The subtraction stays the same. And now I'm going to do the same over here. 1 times 5 is 5. And 9 times 5 is 45. Again, chose that number on purpose so that we could have matching denominators. And now that we do, we can just subtract not the bottom numbers. The bottom number will stay a 45. But those top numbers, 27, subtract 5. I'm going to do that. And I get an answer of 22 over 45. So that's our final answer. And we were able to do it because we made those denominators common. Here's a second example. And you could take a minute at this point and pause the video and try this one on your own. Or I'm going to kind of give you a second option of how to do these questions. So why don't you take a minute, pause the video, try this guy, and then I'll come back and do it with you. All right, guys, so hopefully you did that. And if you used this method where you made the lists with 32 and 4, that would have worked for you. And what you probably noticed is that you actually used 32. When you made that list of 32, the very top number was what you used. You didn't have to change this one at all. And if you are going into an industry like a trade where the reason that you're getting comfortable with fractions here now is because you're going to use a tape measure, then you are only going to be using denominators like 2, 4, 8, 16, 32, 64. You're going to stick with those denominators. There's 2 of them here. And if that's the case, if you're dealing with those numbers on a tape measure, something that's going to work for you, a little bit easier than that method, is looking at these 2 denominators. If I look at the smallest of the 2, I can always multiply the smaller one by something to make it into the bigger one. And in this case, 4 times something is going to give me 32. If I know that, fantastic. If I don't, I can take the larger, 32, divide that by 4, get my answer, and my answer is what I'm going to multiply 4 by to get 32. If I do that to the bottom, I do the same to the top, just like I did over there. So let's rewrite this fraction. And again, you would have noticed whether you used this list method or you did it this way, the 32, the first fraction doesn't change at all, but the second one does. 8 times 1 is 8. 4 times 8 is 32. And now I can really easily subtract 15, subtract 8. Denominator stays the same. So 32 is my denominator, and 7/32 is my solution there. So give me a minute to make a little bit more room, and then we'll try a few more of these. Okay guys, I'm back, and we're going to take a look at a couple more examples. And in the examples I have here floating above my head, you can see that they are all mixed numbers. So they are values that have not only a whole number, like the 10 or the 3 or the 2, but a fraction as well. But the rules don't change. We still need a common denominator, meaning the bottom numbers need to be the same. But as far as the big numbers go, they can just stay large numbers the way they are. So let's try one more of these. And this one, I've got 5.5 subtract 2 and 3/16. Now you know from the previous examples that we did that those two denominators need to match. They need to be the same. So why don't you take a minute and give that one a shot, try that one on your own, and then come back and we will check our answer together. All right, guys. So let's take a look at this first one, which I hope that you've done on your own. And what I hope you did was you looked at 2 and 16, our two denominators, and you said, okay, 2 is the smaller of the two, so that's the one I'm going to change. If you can see, I'm sticking to examples now that you would find on a tape measure. So we can do that. And you multiply your 2 by something to make it 16. And hopefully you were able to figure out that 2 times 8 would give you 16. To do the same to the top. If you're still using that list method like we talked about at the beginning of the video, it's going to work the same. You can continue to use that if you're comfortable. Okay, so let's rewrite this question. I've got 5 and now 8/16. Subtract 2 and 3/16. And then our final answer, I'm just going to take my whole numbers, 5 subtract 2, so that's 3. Subtract my numerators. And my denominator is going to stay the same. That's 16ths. So 3 and 5/16 is my answer there. I have two more examples, and they're similar, and they're a little bit different than we have over here. But let's start the question, and then it'll kind of come out why they are a little bit different. So I've got 10.5 subtract 3 and 7/8. So if we approach this question the same way we did over here, we would say, okay, we need to make those denominators the same. So 2 is the smaller denominator, and I'm going to multiply that 2 by 4, and it will turn into an 8. So now I've got 10 and 4. 1 times 4 is 4, and 2 times 4 is 8, so my denominator is an 8 now. Great. Subtract 3 and 7/8. Now at this point over here, we just did our subtraction, but if you take a minute and look at what we're dealing with here, we could do 10 subtract 3, but when we get to 4 subtract 7, we're stuck. That doesn't really work. But 10 and 4/8 is bigger than 3 and 7/8. This is a bigger number. The reason we're stuck is because we've just got a smaller numerator. So what we're going to do is we are going to, and I'm going to write it here in a different color just so it stands out, we are going to borrow. If you've ever done long subtraction, borrowing comes up there as well. So we take a look at this and we say, okay, 10 and 4/8, that's not going to work for us because that 4 is too small to subtract a 7 from. So what I'm going to do is I'm going to borrow 1 from that 10. So instead of writing a 10 on the next line, I'm going to write a 9. I've borrowed 1. I've taken 1 away. And hopefully it makes sense to you, and maybe I'll write this down at the bottom, that this 1 whole, the one I took away, would be equal to 8/8. Because if you did that in your calculator, a fraction's just a division question. 8 divided by 8, that's just 1. but I could write it this way. So I've actually borrowed 8/8 when I took that 1 away. So I'm going to add that 8 to the 4 I have up here, and I actually now have 12/8. It looks kind of funny because the numerator is bigger than the denominator, but I had to do that in order to subtract. So 10 and 4/8 is the same as 9 and 12/8. We've just reorganized it so that we can subtract. Let's put our second one here. So I've got 3 and 7/8. And now the question's doable. Now I'm going to subtract 9 subtract 3, which is 6, and 12 to subtract 7, which is 5. Sometimes talking and thinking is tough. So my final answer is 6 and 5/8, but I had to borrow to do that. So I've got one more question here for you. And if you want to take a minute, try that question on your own. There's some borrowing in it, and you can kind of practice that method. And I'll come back and check in with you, and we'll check our answers together. So I hope that you did that, and we are now going to take a minute and do this question together. So step 1 in any one of these questions is to make the denominators the same. So looking at the two denominators, this guy is smaller, and if I multiply the smaller one by 8, it will become the larger one. So I now have 4 and 8/16, which is the same as 4 1/2, just another way of writing it. Subtract 15/16. And now I'm going to borrow. I am going to take away 1 4. But that 4, it's not worth 8 anymore. It's worth 16. That 1 that I took is like taking away 16/16. So what I'm always going to do, what I did here is I added the denominator to the numerator. 8 plus 4 is 12. I'm going to do the same thing. 16 plus 8. So I'm going to end up with 24 for 16. Those two mean the same thing, but that now we've written it so that we can deal with subtracting 15/16 from it. And then my final answer. Now, in all the other questions, the larger numbers, I had numbers to subtract. Here, there's a 3 subtract. There's no whole number, so it just stays a 3. That 3 doesn't change. But I do subtract these. So 24 subtract 15 is 9, and the 16 doesn't change. So my final answer is 3 and 9/16. So hopefully that clarifies for you the method of subtracting fractions.